are easier ways of there's easier ways of showing that things are happening. When we did this, remember how we kind of been building through all this whole entire unit is that when we first started, I said, hey, solve this equation. You cross multiplied and solved. After that, we did AB was the BC, as DE was the EF. And then you went and said, hey, that is x over 3, which was 6 over 9. You cross multiplied and solved. And then you went from triangle ABC is similar to triangle DEF, which then you went to this, then you went to that, and then you said x equals something. Then we went to draw the triangles. You had two angles that were the same, which led you to be able to write this, which led you to be able to write this, which led you to be able to write this, which meant you could do that. So, what's that? Well, the idea was is that different types of scenarios are going to allow us to do the stuff we've been doing since last week. And this stuff, for most of you guys, we've gotten to the point where it's the same thing over and over again. It's just a matter of writing it out. So what we've had here is one of the first similarities was that if you had two angles that were the same in both triangles were similar, sides were proportional, you could write the statement and go on from there. Very, very straightforward. Well, the other two are you have versions of side, 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 and a side angle side that allows you to do basically the exact same thing. So if you think about when we had angles, if you had two angles that were congruent, that meant that the third angles were congruent, no matter what. It always happened. So you had similarity. Well, now, if you have three sides, if three corresponding sides between two triangles are proportional, triangles are similar. That's it. So basically, what you're going to check is if and this basically is exactly the same thing that we did here by showing that two polygons were the same. You guys went through all and checked all the side lengths to see if they had the same proportions. Well, all you're doing that now, instead of being in polygons, we're just sticking in triangles. And that's it. So what happens is that we're going to look at, we'll look at diagrams. We're going to pick letters to go and check and see which version of moving your side links, not moving side links, but the organization of the lettering. We're going to check to see if it's going to work. And we kind of did a little bit of this before. Remember the problem we had, I think Monday on that worksheet where it said your side links were 6, 8, and 10 respectively, and then the smallest side link for the other triangle was an 8. You knew that the 8 and the 6 had to match up because they were the smallest. Then the 8 and the other side and so on. You were going by small side is the small side, medium side to medium side, large side to large side. If you keep that type of a correspondence, that's how it all works. And it falls into place that fast. Okay? But it's just a matter of looking at the diagram, taking your side links to go, and writing it out. By now, we all know how to use the calculators to check and see if the fractions simplify. And if that works, then you're done. It's that quick. Shall we look at an example? Or do you want your homework? All right. So,
just give us homework.
Here's what I want to look at. We have two triangles here. Sorry about my crummy handwriting. I tried my best. We have two triangles. The question was, is either triangle PQR or triangle STU similar to triangle XYZ? So what you want to look at here is we're trying to check is this triangle, the green one, or the blue triangle, similar to the black triangle. That's what you're trying to check to see. So what you're doing is, the easiest way is to check it via knowing which side length is the longest and the shortest and the medium, and match those up. Okay? My suggestion, we're trying to see if something is similar to the to XYZ. So what I would do first of all is write out the XYZ triangle. You know how we do the letters for the fractions? I'd write that out twice. Okay? What I mean by that is, you know how we've always done our fractions to check? If we write it out twice, then you can check it with both the blue triangle and the green triangle. So here's what I'll put it on the whiteboard so we have a little more space here. So XYZ, 30, I'm going to go 15, 25, 30. I'm going to go in terms of small, medium, large, okay? So this is for triangle. Actually, you know what? I should probably keep it in order of XYZ for now. No, it's okay. So I'm looking at YZ is the small one. YZ is the second two letters. So in triangle STU, the second two letters are what? Well, YZ are these two. So TU, does that match up? So it'd be 20. The second one was 25, was the XY. That's the first two. That goes to ST. And the last one was XZ, first and last, that would be SU. If you look at those three fractions, just by following your letters through, you can tell right away, are those going to be similar? No, they're not. Because all three, one of those fractions equals 1, the other fraction equals larger than 1, and the first fraction is less than 1. Last time I checked, 1, bigger than 1, and smaller than 1 are all different numbers. So I know that they're not similar between XYZ and STU.
42.
Don't work. Okay. I do that again. I look at the XYZ. I'll put it again in terms of how we did small, medium, large. We went 15, 25, and 30. And really, the idea here is to make sure you keep the letters checked, okay? So if you're going to go with small, medium, large, well, remember, small in this case is YZ, second two.
QR.
Has to go QR, which is 21. I went to XY for the second one. That was 25. The second, or the first two letters of the other one was PQ, 35. And then the last one, XZ, PR is 42. So I'm going to check these three fractions. Well, that's 5/7. That is 5/7. Hey, that is 5/7. So,
That's how you check how they're similar.
yeah, always go by the letters. Now, you could have done it, you could have listed it out a whole bunch of different ways. Absolutely. But my suggestion is if you label it out small, medium, large, then you might be crossed up sometimes by your letters. But if you list them out in terms of letters, X, Y, Z, that means you would have done just a little bit different. It would have looked like this. I'm going to show you guys both ways. It's totally up to you. You would have done X, Y, Y, Z, Z, X. Then you would check that over S, T, T, U, U, S.
Whenever I hear speed, I think of stupid too.
And then you have, the other one was PQR, so PQ, QR, and RP. And what I'm saying here, guys, is that it might not be in that small, medium, large range. You just fill it in different blanks, okay? So you have 30 over 15. YZ is 15 over 20. ZX 30 over 30. So it's kind of the same, but you're just checking via the letters this way versus silence to match up. Does that make sense? Either
Guys,
way,
yeah, because we did that the
we-
other day.
we normally,
This way.
we've
So
done
that
it this
makes
way a
sense.
lot.
Yeah.
And it's not bad to set up that way if you're trying to verify with the numbers, but the trick is, if you're doing it that way with numbers, you have to be really careful with letters. So if you want to fall back just to what we've been doing normally. Okay. Yeah. What's up? So that's how that would work then. Now, you can do the exact same thing then if you throw algebra in it. When we start throwing algebra in it, it'll say something like this. It'll say, find the value of x such that triangles A, B, C, and D, E, F are going to be similar. Which just means that if their two triangles are going to be similar, you have to have that proportionality statement written out. You have to have each one of those three fractions equal each other. Well, just like we've done before, we've told you that they were similar, find x. Now it's find x that makes them similar. Guess what? You do the same thing. We do the exact same thing. So they're telling you, find the value of x that makes ABC similar to DEF.
Wow.
What do you think you do first? Write out the letters, exactly. We write out the letters, you got AB, BC, CA. And then you have DE, EF, and FD. Which means, fill in the blanks.
D stands for discriminant word.
Okay, awesome. In your mind. Okay, thank you. So we go back, we start filling them back in. AB, 4. DE, 12. BC is x minus 1. And what is it? EF is 18. CA is 8. And then 3 times x plus 1. So you're probably noticing right away that you're going to get some sort of a scale factor here. 1/3, very good. So I'll use this fraction to solve for x. 1/3, bless you. Cross multiply out, you get 18 is 3x minus 3. And you get 7. Okay. So what happens here is that you're just, we're doing the same exact problem that we did in section 6.2. You were in 6.2, you were told they were similar, find x. Well here, find x that makes them similar. It's the same stuff. Okay? It's just working backwards. Okay? Sorry, I don't mean to keep you up. What's wrong, man?
How did you get the orange stuff on top?
I used my hand and I pushed pressure.
Like,
Where'd I get the numbers? Where'd I get the 1/3?
yeah.
4 over 12 simplifies. I could have left it at 4 over 12 and used my calculator, but 4 over 12, you simplify it to the scale factor of 1/3. I cross multiplied, 1 times 18 is 18. 3 times the x minus 1 is 3x minus 3. I distributed here. I just did that in my head in one step. And then it's a two-step equation. Add 3, divide by 3, I get 7.
Because I did it and I got 36. I did it wrong now.
All right. The other version The other version of this works out to be a version of side angle side, where instead of having to have all 3 sides proportional, in this case if you just have 2 sides that are proportional, and the angle between those 2 sides congruent, then it works. So this looks a lot like side angle side. But instead of the sides being congruent, the sides are proportional. Okay. So what you'll wind up with is you're going to be given 2 sets of side lengths and an angle congruent between the 2, and it's just a matter of the questions will be very much like the one we just did, where it says find the value of x that makes them similar. Well, instead of having to go through all 3 side lengths, all you have to do is go through 2 of them. Stuff this every once in a while in the year, but it's much better. Okay. So 2 sides of triangles are proportional. The angle between them is the same. You've got similar triangles. Okay. Give me a second to write that, and I'll show you an example. Do. Find the value of x. Yeah, that's it. Right. Find the value of x that makes PQR similar to TUV. No, I don't. 60! Yeah. 60!
Calm down.
So,
That's where you're wrong.
again, they're giving you the 2 side lengths. Use it in terms of proportion. They're trying to show you what the value has to be. So the idea here is, well, PR and QR, so you've got going from left to right. All I would do, I'd have PR and QR moving from left to right. Okay. So PR, first last, matches up with TV, first last. Second, third, UV. You're going to be given some statement. Use the lettering off the statement from what you know. Fill in the blanks, cross multiply and solve. So let's see. 3x is to 20. That's 30 is to 24. Now, could I use 30 over 24, or could I simplify that and use a scale factor? Yeah, I would simplify it just because it's a little bit easier. Because I don't have a calculator in my brain. But I know that 30 over 24 are both divisible by 6. So you get 5/4. So 3x plus 4 over 20 is 5/4. So 4 times the quantity, 3x plus 4, is 100. Now there's 2 ways you can do it from here.
Wait, how many numbers is
5 times 20. Cross multiply. Fraction equal fraction, cross multiply. You don't like it when I skip a step, do
that?
you?
No, I'm so confused.
All I did was this.
12x plus 6.
I just simplified it right off the bat. It's right here. And then you're at a 2-step problem. Subtract the 16, divide out by the 12. Okay. There's going to be more than one. There's more than one ways to set a lot of this stuff through. Okay. Yeah, and I'm sorry. I skip steps a lot because I don't know. I try not to, but sorry.
Oh, wow.
Hey, Mitch.
Where did that?
I'm not allowed to scratch.
Didn't see that one?
Right in the middle of my back, I can't reach it. I got long arms, but they just don't.
Jordan.
My back's right.
I saw it.
Yeah, I can
It's only
definitely.
$1.
There's a Christmas present. I have this. It sounds like so like fun. But I went to like go get gas one time, and this girl like used like this stick, and it had like a cork cob on it, and like you could like scratch your back with it.
You can buy
I know that sounds really pathetic, but it works really good.
That's awesome.
Sounds really pathetic.
That is awesome.
Yeah,
So it sounds really
No,
pathetic.
maybe I'll make some for all my.
Sonny D. We call you Sunshine.
Oops, that didn't work.
Would you rather be called Sonny D?
Think with a bunch of pine
It's just a drink.
So one of the questions that you'll see from time to time is something that looks like this. Where they're going to say, sketch the 2 triangles, fill in the blanks, and determine whether or not the 2 are similar. Okay? So they're going to give you information. They're going to give you information. They say that triangle ABC has B at 60, segment AB is 6, BC is 12. So make a visual of what that looks like. Okay? You start sketching it because they want you to tell whether or not these 2 are going to be similar. So, $60 there, AB is 6, and BC is 12. So with just that information, it's setting us up to try to determine whether or not the side angle side version of this stuff is going to work. It's trying to see if the 2 sides are going to be proportional and the angle in between the same. I'll do the same idea. They have y at 60, xy at 3, and yz at 6.
Yes.
The 2 angles match up, don't they? They're middle letters, middle angles, both 60. Then if you check the side lengths, AB is 6. The corresponding one to the other side would have been XY. BC is 12. The other one is that a true statement? Yeah. Are they similar? Yeah. That's what you're looking at being able to do. Okay? You can if you'd like, but if you from there, I'm fine if you know that you can say, yep, they're similar, because 6 over 3 is 2, 12 over 6 is 12. Yes, I'm not going to make you say 2 equals 2, but if you know, if you can say yes, these 2 are similar. that's fine.
Wait, 2 equals 2?
Last time I checked, yes.
That's not I thought negative 2 doesn't equal positive 2.
You're right, -2 does not equal positive 2. All right,
Huh?
try that one. Same deal. Draw it. You can't just visually, you gotta put it on paper, it's much easier. I know it's hard to believe.
Don't you have paper in your locker?
No,
Oh, the dollar store this week.
I don't have any.
You don't have any. Shame on you. Sunshine.
Roll. First one.
Well, you start out, you've got B and Y are the same, that's good. But we gotta figure out the missing third angle to see if it works, okay? It's a real tough question. How many degrees are in a triangle? 180. Okay, so back out 80, you're at 100. Back out 15, you're at, hey, look at that. Are they similar?
No.
They're the same. They call you sunshine.
Again, are they similar?
Oh, yeah.
Thank you.
No problem.
Do those.
I'm done. That's it. So.
Okay. We'll do those tonight. Tomorrow we've got one last little run through of 2 basic setups of writing out similarities that aren't, side angle side or anything like that. I have really, really nice shortcuts for all the definitions. You don't even need to learn a definition. All you need to be able to do is look at a picture and draw a heart or a fraction bar.
How do you draw a heart?
So.
Hey, Mr. Murphy.
Yes, sir.
A heart is like one of the hardest things to draw.
Right, I know.
I mean, a human heart.
You ever see this? The angle bisector?
Whiskey, you know sunshine.
The angle
uh,
bisector creates similar triangles.
No, I mean sunshine.
Whiskey, why do you want to call it sunshine? That's why you're right.
That's what it is.
That's why you're right.
Wow. Oh, would any of that mean?
I love
Exactly. I like how
That was funny. Jacob, you remember when Austin called him sunshine?
So is it because it is an online thing?
Well, we can see that all day long.
gonna be that again?
What are you trying to do?
the man's trying
I was just trying to switch my
Stop being so tall.
Yeah, I mean, that was the plan. Like 7th grade.
Hey, just wait till you start trying to find dress shirts.